Welcome back to our discussion about double angle identities. In this video, we're going to look at something similar to the example we examined in the second video, but in this case, we are given not a right triangle, but the sine of a given angle and the location of that given angle. And then we want to find the three principal trig functions of twice that angle or double that angle. So let's jump in and see what we can do here. So this is what we know. Alpha lies in quadrant 3, and the sine of alpha is negative 9 over 41. Okay, so we know something about a specific angle. Now we want to find the sine of 2 alpha, the cosine of 2 alpha, and the tangent of 2 alpha. And we want these to be exact values. Okay, so first, we know a little bit about alpha, but we don't know enough to actually find these exact values. So what we are going to need is, not only are we going to need the sine of alpha, but we're going to need the cosine of alpha and the tangent of alpha. Lucky for us, we know enough about what sine represents to calculate cosine and tangent. So there are lots of different ways that we can do this, but this is how we're going to approach it. We know that since the sine of alpha is negative 9 over 41, we can say that some point on alpha has a y value of negative 9 and a radius of 41, or a hypotenuse of 41. Opposite over hypotenuse, right? Well, that gives us enough to solve for the x value. So we can use this relationship, x squared plus y squared equals r squared. And we can say, all right, plug in the y, plug in the r. X squared plus negative 9 squared is equal to 41 squared, which is going to give us that x squared is equal to 41 squared minus negative 9 squared, which is also known as 1600. Okay, so what does that mean? That means that x is going to be plus or minus the square root of 1600, so plus or minus 40. Well, which one is it? Well, that's where we go back to the location of alpha. Alpha is in quadrant 3, and what do we know about x values in quadrant 3? We know that they are negative. So we know that x is going to be negative 40, and the hypotenuse is positive 41. So that means that the cosine of alpha is going to be negative 40 over 41. Well, now we have our x as negative 40, our y as negative 9, and our r as 41. That also means that we can identify the tangent of alpha as y over x, or positive 9 over 40, right? And we also know that tangent in quadrant 3 is going to be positive, so that lines up very well. So now we're going to use our sine, cosine, and tangent of alpha to find our sine, cosine, and tangent of 2 alpha using our identities. So let's start with the sine of 2 alpha. We can use a double angle formula here. We know that the sine of 2 alpha is equal to 2 times the sine of alpha times the cosine of alpha. So we can take what we know the sine of alpha to be. Sine of alpha is negative 9 over 41. So we're going to replace this whole thing right here with negative 9 over 41. We know that the cosine of alpha is negative 40 over 41. So we can replace this whole thing with negative 40 over 41. And now we can just multiply. We're going to take and multiply 2 times 9 times 40. And this negative is just going to become positive. So 2 times 9 times 40. And then we're going to place that over 1 times 41 times 41. And our answer here will just be positive 720 over 1681. Okay, good deal. Let's try cosine of 2 alpha. Let's go ahead and use our preferred cosine of a double angle formula, cosine squared of alpha minus sine squared of alpha. Our cosine we know to be negative 40 over 41. We're going to square that right here. And then from that, we're going to subtract the sine of alpha, negative 9 over 41, and we're going to square that right here. So it kind of looks like this. All right, now when we square both of these things, of course they become positive. And so we would end up with positive 1600 over 1681 here, and positive 81 over 1681 here. All right, and so we end up with 1600 minus 81 over 1681, which is 1519 over 1681. All right, and then the last bit here, our tangent of 2 alpha, you can always go back, and since we have the sine and cosine, we could use what we know about the tangent of 2 alpha equaling the sine of 2 alpha over the cosine of 2 alpha. We could use that, or we could go through the process of finding such things with just our formula. We can go ahead and substitute in our tangent of alpha here, which is 9 over 40, and here as well, 9 over 40, and then square it. All right, so we sub those things in. Now let's simplify things. If I multiply this out, I've got this, I can take this 2 and 40 and simplify that as 1 and 20, so this becomes 9 over 20. And then here we have 1 minus, if I square this thing, it's 9 times 9 over 40 times 40, or 81 over 1600. Making a common denominator here of 1600 over 1600, so I could simplify this. Okay, and our next step would be to combine these like terms, 1600 minus 81. So I would end up with 1519 over 1600. So I have 9 divided by 20, all divided by 1519 over 1600. So remember that complex fraction bit, we're going to keep the numerator, change this into multiplication, and then multiply by the reciprocal here. So when we do that, we end up with this big old number, okay, which we can then simplify, use our calculator to simplify. Or we could have simplified right here. We can take this 20 and the 1600 and make this into 80 and 1, and that would also make it easier to simplify. That would give us a net result of 720 over 1519. See you next time.